Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today, spiral matrix, Leetcode 54. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are given an m into n matrix and our task is to return all elements of the matrix in the spiral order, where we start at the top left corner and move rightwards, collecting the elements 1, 2 and 3. Then go downwards, collecting the elements 6 and 9, followed by left, collecting elements 8 and 7, and then up, collecting element 4, and then move right again, collecting the element 5. And now since we have visited all the elements, we will return this matrix as a list in the spiral order. Similarly, in example 2, we start with the top left corner. Then we move rightwards, collecting the elements 1, 2, 3 and 4. Then we go down, collecting 8 and 12. Then we go left, collecting 11, 10 and 9. Then up, collecting 5. And then right again, collecting 6 and 7. And now as we have visited all the elements, we are done and hence we will return this matrix as a list in the spiral order. Now let's see how we can solve this problem. We start at the top left corner of the matrix and move from left to right, collecting the elements 1, 2, 3 and 4. At this point, we have reached the end of this row, so we can no longer go further. So we move downwards and collect the elements 8 and 12. And again we have hit the boundary, so it's time to change the direction. So now we go left and collect the elements 11, 10 and 9, where again we have hit the boundary. So we move up and collect the element 5. And note that we don't collect 1 again because it was already collected earlier during the traversal of the top row from left to right. And once we reach this top edge, we are done with the outer rectangle. And what remains now is an inner rectangle, which is smaller but requires the same process where we again start from the top left corner of this rectangle and go rightwards, just like we did for the outer rectangle where we went rightwards, then downwards, leftwards and finally upwards. So as we traverse, we are continuously shrinking the rectangle layer until all the elements are processed. We can define rectangle layers using 4 boundaries: left, right, top and bottom. And as we shrink the rectangle, we adjust the boundaries by moving top downwards, right moves inward, then bottom goes upwards and left moves inwards. So this helps us focus on the smaller inner rectangles. Now let's quickly revisit the matrix traversal in spiral order using these boundaries. So we'll define the 4 boundaries as top, right, bottom and left. First we go from left to right along the top boundary. So we collect the elements 1, 2, 3 and 4. And now we have processed the top row. So we can shrink the top boundary downwards by incrementing its value. And now we process the elements along the right boundary, moving from top to bottom and cover the elements 8 and 12. And once we are done with this, we shrink the right boundary inwards by decrementing its value to reflect the inner rectangle. And now we process the elements along the bottom row, moving from right to left and cover the elements 11, 10 and 9. And after this, we shrink the bottom boundary by decrementing its value. And now we process the left column, traversing from bottom to top, collecting element 5 and shrink the left boundary inwards by incrementing its value. And now we have completed a full cycle covering the outer rectangle. Next, we repeat the same process for the inner rectangle. And once again, we traverse along the top boundary, moving from left boundary until we hit the right boundary, collecting the elements 6 and 7. And now, since we are done with this top boundary, we shrink it by incrementing its value. And at this point, we can stop. Why? Because now boundary conditions become invalid, as here top is greater than bottom. And visually we can see that top has moved beyond the bottom, making it impossible to form a rectangle. Similarly, we should also check if left is greater than right. In such a case also, a rectangle can't be formed. So if either of these conditions is true, we stop the iteration. So this is one way to determine when to stop. Another approach is to monitor the size of the spiral list, which is the answer we want to return. If its size is equal to m into n, where m is number of rows and n is number of columns, then total number of elements in the matrix will be m into n. And if the size of the list is m into n, then we know that all elements in the matrix have been visited. Thus, we can stop the traversal. So you can choose either method, boundary conditions or the size of the spiral list to determine when to stop the iteration. Now the time complexity of this approach is O of m into n because every element of the matrix is visited exactly once, and the additional space complexity will be O of 1 because we are using few variables for the boundaries like top, bottom, left and right, storing the result in the list which we anyways need to return as the answer. Here is a quick code walkthrough of the algorithm we just talked about with Java code on left and Python on right. First, let's initialize an empty list, answer, which will store the elements in the spiral order. Next, we will initialize the 4 boundaries, top, bottom, left and right, to represent the current boundaries of the rectangle or submatrix we are processing. The top boundary starts at row 0 and bottom starts at the last row of the matrix, which is length of the matrix minus 1. Similarly, the left starts at the first column and right starts at the last column. Now we will enter the while loop to process the elements in the spiral order, which runs until the boundary conditions are valid. That is, top is less than equal to bottom and left is less than equal to right. First, we iterate from left to right along the top boundary and append all elements in this row to the answer list and shrink the top boundary by incrementing it after processing this row. Then we will iterate from top to bottom along the right boundary, appending all elements in this column to the answer and shrink this boundary by decrementing right after processing this column. At this point, we have shrunk top and right boundaries and we now need to cover the elements along the bottom and left boundaries. However, there is a chance that due to the shrinking of top and right, the boundary conditions may have become invalid. That is, either top would have been greater than bottom or left is greater than right. So if either condition is true, it means there are no more elements to process. So we can break out of this loop immediately. Otherwise, if the boundary conditions are still valid, we traverse the bottom row by iterating from right to left along the bottom boundary, appending all elements in this row to answer and decrementing bottom to shrink the boundary after processing this row. And finally, we traverse the left column by iterating from bottom to top along the left boundary, appending all elements in this column to answer and increment left to shrink the boundary after processing this column. And we continue processing new rectangles formed by shrinking boundaries until all the elements are added to answer. And in the end, we will return the answer which contains all matrix elements in the spiral order. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.